In this video, I'd like to talk about the average value of a function. Now, I have a problem to work through here, but before we get to the problem, I want to talk a little bit more generally about what I mean by the average value of a function. Let's start with this. Let's say you have a rectangle, and you know the area of this rectangle is equal to, let's say, 25 square units. And you know the base of this rectangle is 4 units. Can we figure out the height? Well, sure. Area of a rectangle is equal to base times height, so 4 times y should equal 25. Yeah, no problem there. Divide by 4. So y is equal to 25 over 4, or 6.25. So as long as we have two of the three values, area equals base times height, as long as we have two of those three values, we could solve for the other one. All right, so now let's shift this to our discussion in calculus. Let's say we have a area that's not a rectangle. So let's say we have some function. Let's just look on the interval a to b, and we have the graph of some function. Let's say it starts here and it ends here, and it looks something like this. Well, we know that using calculus, we could find the area under this graph. So this is the graph of f of x, or at least a portion of the graph on the interval a to b. And we know that since all of these, since the function is non-negative on the entire interval a to b, then the area should equal the integral from a to b of f of x dx. And we could evaluate this using Riemann sums if you want, and limits, or more efficiently, the fundamental theorem of calculus. So now that we have an area, we should be able to create a rectangle that has the same area as the shaded region here on this graph. And so if the rectangle has the same base from a to b, it would probably be something like this. We can make a rectangle that has the same area in green as the area in black. And so we know this green area, if we choose the right height, we'll have the same area as the area under the function. All right, so the base of that rectangle, we know that's b minus a. So that's the base of the rectangle, and the height is this unknown y value. So base times height equals area. So now we could say that the base, which is b minus a, times the height, which is y, should equal the area, which is the integral from a to b of f of x dx. And let's say we know a, we know b, we know the function f of x, so we could find the area. The unknown here is y, so let's divide both sides of this equation by the base of the rectangle, or by b minus a. So y is equal to 1 over b minus a times the integral from a to b of f of x dx. So this value of y right here, this is called the average value. Average function value, or the average value of the function. So it's basically the height of a rectangle on the same interval that gives the exact same area as the area under the curve. Okay, and so this is, I'll put this in a box because this is our formula for the average value of a function. All right. We don't actually need a picture to solve the problem. We don't have to graph the function, but the graph helps in terms of visually understanding what's going on behind the scenes. So now let's look at this actual problem. We have the function f of x equals 4 times the quantity x squared plus 1 over x squared on the interval 1 to 3. All right, so let's see what we got. A is 1, B is 3, so that's our interval 1 to 3. So the base of the rectangle b minus a would be 2, and our function f of x is equal to 4 times x squared plus 1 over x squared. All right, so what we're basically doing in this problem, find the average value of the function, that's the y value, and also find all x values in the interval for which f of x equals the average value. So what this question is asking us to do is to find this point right here, the x value and the y value. The y value, we have this formula right here. The y value is the average value of the function, and then we also want to know what is that x value. Okay, so that's what we're looking for in this problem, the x and the y value. We'll find the y value first because we have this formula for the average value of the function, which is the y value. Okay, so let's come back down here. So the average value of the function should equal 1 over b minus a, which in this case is 1 over 2. 3 minus 1 is 2, so it's 1 over 2, times the integral from a to b, so from 1 to 3, of the function 4 x squared plus 1 over x squared dx. Well, before we integrate this, let's simplify this sum so we have an easier process doing the integration. Well, this 4 could come out front, so the 4 and the 1/2, that becomes a 2. So we could say y equals, we have a 2 on the outside, integral from 1 to 3, and now the x squared over x squared, that equals 1. And 1 over x squared, that is x to the negative 2 power. Okay, so a little bit of algebraic simplification. So now we're integrating 1 plus x to the negative 2 power. And that's simple enough. So we have a 2 on the outside. The antiderivative of 1 is x. And the antiderivative of x to the negative 2, well, applying the power rule for integration, we add 1 to the exponent and then divide by that new exponent. So x to the negative 1 divided by negative 1. So that would be minus x to the negative 1 power, or minus 1 over x. All right, and we're evaluating this according to the fundamental theorem of calculus from 1 to 3. So we plug in 3 for x, and then we plug in 1 for x, and then we subtract the results. Okay, so that's a 2 on the outside. And I'm just going to write it all out. Maybe I'm writing a little more than you may normally do, but if we plug in 3, we'll have 3 minus 1/3. Let me actually change colors just a little bit here so it's maybe easier to follow. We're integrating from 1 to 3, so we're plugging in 3 minus 1 over 3. So that's plugging in the 3 first, and then subtracting 1 minus 1 over 1, which will give us 0. All right, so 3 minus 1/3 minus 1 minus 1, so minus 0. So we have 2 times, well, 3 minus 1 over 3, that's 8/3. So we get 16 over 3. All right, so that's the average value of the function. Average value of f of x. Okay, so I'm going to scroll back up to the graph. So now this point right here in red, we just found the y value. The y value of that point. And now this is not the graph of for x² plus 1 over x², but just in general, we found the y value of this point, or the height of the rectangle. All right, so if we know the y value, now we could solve for the x value. So now step 2, solve for x. So step 1 was solve for y. Solve for y, which we did up here. And now step 2, solve for x. So we know that the y value is equal to 16 over 3. And y equals f of x, and f of x is our function. So 4 times x² plus 1 over x², that's the function, that's f of x, which is y, equals 16 over 3. So now we just have to solve for x. So we could do maybe some cross multiplying here. So we could say 3 times the numerator here, so that's 12 x² plus 1 equals 16x². We could distribute the 12. So here we cross multiplied. Now distribute the 12. So 12x² plus 12 equals 16x². Or we could subtract 12x² from both sides. So we have 4x² on the right. Divide both sides by 4. So x² is equal to 3. And take the square root. X equals plus or minus the square root of 3. Now so this means there's 2 x values that have a function value of 16 over 3, or 2 x values that when you plug them into the function, you get 16 over 3. The only one that's in our interval, so our interval is positive 1 to positive 3, so the only one in the interval is the positive square root of 3. All right, so that answers the question. Find the average value of the function, that's the 16 over 3, and then find all x values in the interval whose function value is 16 over 3. So that's the square root of 3. Now, there could be more. You could get possibly more than one x values. Let's say, so this problem is done, but let's just say, how would you get more than one answer? How would you get more than one answer? Well, what if the graph looks something like this? And we're looking at the area under this graph. So this is the graph of some other function f of x. Well, then the rectangle that has the same area might look something like this. So now this green rectangle might have the same, well, let's say this green area has the same exact shaded area as the black. So that means there's an x value here whose y value is the height. We'll call it x1. There's an x value here whose y value is the height, x2, and we'll call this x3. So this is what it would look like visually in a case where you have more than one answer, more than one x value. There's only going to be one y value. There's only going to be one height of the rectangle, but there could be multiple x values associated with that y value. Okay, in this case there wasn't, there was just one, but that's it. That does it for the average value of the function. Find the y value first, find the x value second, and essentially what you're doing is you're looking for this point right here, this point in red, xy. The y is the average value, and the x is basically where the average value happens. All right, that does it for this problem. I hope it was helpful.